Fantastic. Thank you so much. Well, thanks for having us here. My name is Alex. This is Roland. Roland is going to do the Maya part of this presentation today, and I'm a 3ds Max guy. And yeah, we are both excited to be here. First time Digital Dragons, after all. I hope you can still, I hope you can still pick up some information after that long day. We'll just try to keep it as brief as possible because I know that we are between you and the beers and the awards, and so it's the final presentation for today. What I've prepared, what I prepared here is just a quick talk about a few specific 3ds Max workflows. So before we hop into this, I would like to do a quick show of hands. Who in here has been working with Max or is currently working with Max out of the audience? That is fantastic. And the other product, which is Maya, who's been working or is working with Maya. Perfect. So we wanted to do initially like a split, maybe like I proposed 40 minutes of Max and 5 minutes of Maya. Roland didn't agree, so it was a long back and forth. But both of us go back a long while where we were at different exhibitions and we were actual competitors to each other, right? So it was always make fun of that. So awesome. What I have prepared, and obviously there's tons of stuff that we potentially could show today, but because of time, I've tried to limit it to a few certain workflows. So modeling and environment workflows I want to talk about. I want to briefly give you an overview on some of the skinning techniques. It's basically just a 2-minute video, but I wanted to emphasize what can be done inside of 3ds Max, and I also have a little bit of an insight towards the future, like an outlook, if you will, regarding retopologizing workflows, UVs, that kind of stuff. So that's basically roadmap. Awesome. So first of all, this is a quick tip here. Who in here is using Booleans from time to time? Okay, quite a few. That's amazing. So I don't know if you are aware, but we integrated a new Boolean operation inside of 3ds Max a while ago, like two or three versions back. And the tricky part here is, and I have to pause this quickly, that it is kind of hidden behind the old legacy Booleans. So if you don't know about this, you will never click on that old traditional Boolean again. Everyone will use pro Booleans and miss out on the new technology right here. And this whole thing goes under the umbrella of non-destructive workflows because as you see here, I'm doing a Boolean operation, but I can obviously go back to the source files, to the components of the Boolean operation. And I can even, what I've just done here is I created a reference. I can even access the Boolean intersections as spline data. So I have 2D shape information about the Boolean intersection. It could be a union or a subtraction, whatever. And with that, I can now, for example, create like a rim line around my Boolean operation, which still is connected to the main Boolean. So I can go back to my main operands, I can move these around and have these outer rims, being created accordingly as I go along. I could even access the spline component and create some sort of a clone along spline modifier, which has been created in Max Creation Graph, MCG. I don't know if anyone ever tried that, but it's kind of the procedural framework that we've integrated into 3ds Max in 3ds Max 2016. And even though it got very low, it didn't adapt very well for a lot of studios, but what we do is we ship tons of operators and modifiers which you can download from the area, and one of these is the clone along the spline operator. So now I have all of this in place and can still go back to the original Boolean operands, and I can change the overall shape, basically go through my art direction process very, very easily. Awesome. The next small but also big thing is the newly developed Chamfer algorithm inside of 3ds Max 2020 actually, which has just been shipped I think 3-4 weeks ago. So, well no, it's end of May, so it's almost 6, 7, 8 weeks ago. Anyway, so this is the legacy Chamfer. I have to pause my video again. There you go. So what I wanted to show you here, that's the way the Chamfer, does it pause? Yes. used to work. So sometimes, when you have a topology like this, which is, sometimes you have some triangles in there or some weird cuts here and there, you would potentially get a very unpredictable chamfer. See that? Like where this line should be parallel to the others, but it actually wanders into the geometry, which is not what you want. So a basic operation like chamfer could actually eat up a lot of your time because you have to tidy up the geometry afterwards, right? So this is compared to the new fixed chamfer that we've integrated. So that's a new algorithm that gives you these very straight lines across your whole geometry, which is, again, a small thing, but speeds up your workflow drastically because it's just very, very predictable in terms of what you want to create and what it's giving you. It has tons of other stuff in there as well. So, for example, what we can do here is we can add the chamfer as a modifier, right? So in here, in the modifier stack, whenever you talk to environment artists, they actually love the 3ds Max modifier stack because it's kind of non-destructive workflow right there. And this, again, gives you great art direction. For example, what you can do is you can define an end bias, which blends in the chamfer amount or the chamfer operation itself into your selected edges. What you can also do is, instead of throwing the chamfer on the whole object, you can filter it by a minimum or maximum angle. So this could be something like, if you have a degree that is sharper than 45 degrees, it should actually apply the chamfer. And because that's a live operator, you can start or continue modeling under the hood on your editor poly, and it will chamfer only those segments that are defined in your angles. You could also do a depth amount, which gives you kind of an inverted chamfer right here. And there are all sorts of different ways of basically selecting what faces you would like to chamfer. Here I'm selecting just a few polygons, and I'm setting the chamfer operator to basically just take my outlines, and by that, including with the, using the inset amount, I can create these kind of panel lines across my geometry very, very quickly. As soon as I'm ready to go and I go like, oh, this is fantastic, I want to use this over and over again, I can use a preset. So this allows you to save this specific setting into an INI file, which you can share with your colleagues. You can put it on a network folder, and others can load it up and use it on any other object in your scene over and over again. So these are some of the things that you can do. You can also use your presets in order to do a weighted chamfering, so you can define where the chamfer should take place, etc. Very, very easily. So here I'm just using a preset modifier in order to define where the chamfering should take place and where not. Awesome. Cool. So that was 2 quick modeling, tips, chamfer and Booleans. The other big thing that I'm a very, very big fan of is the non-destructive workflows combined with proceduralism. So again, this is a little bit about MCG, Max Creation Graph, which you don't have to necessarily learn in order to benefit from it, but you can use it. So here's a shelf filler that basically allows you to define a few prefabs, and you select these prefabs, these pre-made models in your scene, and it will automatically populate a table or a shelf for you. So I'm using here a scene from Warhorse Studios from Kingdom Come Deliverance, and this is basically, again, these are the prefabs that I'm using, and I have boundaries. So these boundaries are basically defining the volume wherein the props or the prefabs could take place in, could be scattered in. And the cool thing about MCG is that you can open up these operators and you can add additional functionalities. For example, we could add biomes, so it would know this is a basement or this is a town area or a castle area, and would pick the prefabs accordingly. And then you can basically go through different seeds and use this as sort of a stamp inside of your environment, go through different seeds, and you bake it back down. The moment you press bake, it basically commits to these changes, and it populates your prefabs with the transforms. So it basically takes or instantiates your prefabs in the scene with its own, well, transforms, and then you can use, for example, a Python XML export and copy all these positions into your game engine very easily. Awesome. All right. Cool. So another cool little feature I think would be using MCG for a projection. And basically this is just a spline, the red one is a path, right? A 2D shape that I've drawn into the scene. And I'm using another MCG to project onto my landscape. So instead of doing kind of a snapping and having to redefine my pathway all and over again as soon as I change my landscape, I'm using a procedural way of projecting down the path onto my landscape right here. And then I'm using that path in order to clone a fence. So cloning, basically, it takes a few different prefabs to construct this, this fence right here. I believe there are 3 or 4 different segments, which it is using over and over again randomly. I can still change my original path and will start reprojecting onto the landscape. I can go into my landscape as well and change the shape of the landscape and have the fences, projected down into my environment accordingly too. Right, so there are tons of different ways to distribute stuff in your scene. Rockstar, for example, they used to use the texture baking method to bake down vertex colors from the ambient occlusion information, and then they can use ambient occlusion vertex colors in order to distribute certain little details in their scene as well. Awesome. So I don't know how much time. We don't have much time. I don't know. I want to quickly show you this. So this is probably more a cinematic prototyping that we see here. So I'm using a method that basically uses a data channel modifier that allows us to transform vertex information and store it or output it into some other modifier or a mode, right? So what I'm doing here, I want to have kind of a footprint from these car tires onto my landscape. So what I'm doing is I'm creating a selection, an interactive selection using the volume select. So wherever there's an intersection between the car tire, can I pause this? Fantastic. Between the car tire and the landscape, it will give you the selection, right? The overlap. I'm converting the selection into a soft selection right here, and then I'm using the data channel modifier, which has tons of additional modifiers in itself. So some people refer to it as a modifier stack and the modifier stack. And here I'm adding a decay, which would transform your soft selection over time and would basically cause like every few frames to fade out the selection, right? And now I can do even more with that. With that selection, I'm going to push in and out some of these vertices. So here I'm going to add to the vertex position, so I'm pushing this outward. And I'm using a little bit of a scale and a ramp, basically a curve, to modify how that push should actually behave. So what I want to do is I want to push it outwards, but directly under the car it should push the landscape or the snow or the sand, doesn't matter what it is at this point, should push it down, right? And all of this can be done in the data channel modifier, fully procedural, so you can change your car tire animation or your footprint animation, your character animation, and it would all update in real time in your viewport. Awesome, cool. So for the sake of time, I want to move forward a little bit because I wanted to give you this little tip here about the skinning. So big thanks to CD Projekt for providing us with Gerald in this specific scene right here. What I wanted to show you is the heatmap skinning and the geodesic voxel binding, which is part of 3ds Max, and not many people are aware of that. So whenever you do a skinning, and you probably just saw that the hands, the gloves, they are not bound at this point, they are not animated. But we have the reference animation on our bone structure. So what I'm going to do is I'm adding a skin modifier, a default skin modifier. I'm adding this to my scene, and as you would potentially expect, this doesn't work very well, right? So the skin weights are off. This is where the work starts to do your paint your weights or use envelopes, etc. So instead of doing this manually, what I'm going to do is a heatmap skinning right here. The beauty about this is that you can be in your reference animation, and whilst you're going to the, I guess, worst part of your skinning, you can tweak your heatmap solving and basically come up with a very good solution on the fly. It also has potentially some bottlenecks. Right here, there's a newly introduced intersection between two different geometries. So that, again, would be something where the heatmap solver didn't do a very good job. So instead of redoing all of this over and over again, like repainting my skin weights, what I'm doing here is I'm just selecting a few vertices where I want to apply the heatmap skinning on, and the rest should be not touched at all. This is kind of static geometry, it shouldn't be bent, etc. So there we go, and I'm just using the skin mirror to mirror the right side over to the left side and have the skin weights done by that. So there are other areas, like for example the boots of gels, where geodesic voxel binding could be very, very nice. So here is the same principle. I'm adding the skin modifier onto the boots, and you will see that the skin weights probably they start looking okay, but then in some extreme situations like this banding, this is all stretched and all over the place, so not really done very well. Geodesic voxel binding solves that on the fly. You can even tweak it inside of your animation, maybe add a little bit of resolution to your voxels for that binding pose. So yeah, pretty cool. And you can mix it up, right? You can mix up voxel binding with heatmap skinning and traditional ways of doing your paint weights. All of this can be done in Max very, very easily. Awesome. So, cool. And that's almost it. This is a quick... This is not really about the ins and outs of animation, but I wanted to make you aware that there are motion paths inside of 3ds Max. So you can, it's basically editable trajectories. So you can start, instead of going into the curve editor or your dope sheet editor, you can start doing basic block outs of your animations directly inside of the viewport by using these motion paths directly in here. So some of the, some cool things right there. Awesome. So finally, before I hand it over to Roland, who's going to talk about Maya, not yet, 3 minutes maybe, I have the roadmap for some Retopo stuff. I hope that makes sense for some of you. I know it's a mixed bag today, so I'm doing a little bit of this and this and that. If you're interested in having like deeper conversations about actual, specific industry workflows, feel free to call us up in the end, and we can do webinars or customer visits. Actually, that's what we do traditionally. Safe harbor statement means whenever we talk about roadmap, we don't guarantee that any of that stuff is actually make it into the product. There's no dates or no commitments really. But again, I wanted to give you some outlook into some research and development we're doing right now. Awesome. So when we talk about modeling, what we want to do and achieve is making your lives easier. So taking away repetitive tasks out of your, I guess, daily work. Repetitive, that is, could be Retopo, it could be UVs, it could be something like baking to texture, depending on your workflow, I'm assuming. So Retopo is crucial for a lot of us, right? So whether that is a Retopo for your texture baking workflow or high-res to low-res, or if it's something simple like creating collisions for your game, right? So it can take up or eat up some time. So this is a prototype of a Retopo modifier directly inside of 3ds Max, where you just define a number of quads and then you're good to go. And this can be cranked down to quite a small amount to give you not only LEDs but actual collisions. What's cool about this is that we also thought about making this a little bit more sophisticated. So if you wanted to have a specific, polyflow, what you can do is you can create guidelines for your Retopo, for the automatic Retopo, and you can use these guidelines, or 3ds Max is going to use these guidelines in order to achieve a certain edge flow or polyflow around your model. I think I'm activating the wireframe any second now. Again, this is a prototype of the technology. We're discussing a lot about this with different game studios. If you have input on that or models that you want to have tested, please let us know, and we can have a look at this together. Awesome. So there is other stuff like automated UVs. These are there's a lot of thought going in this, right? So we are basically investigating deep learning at this point, where we're feeding thousands and thousands of models into the algorithm, and it would actually decide if that's a character or organic model or a hard surface model, and generate UVs out of that in a very sophisticated manner. Almost done. Yes. Awesome. So. And that was that. Texture baking for sure is something we're looking into as well. And I wanted to show you this finally, because character animation was very short and brief for me. So these are character modifiers, so that's how we call this. It involves retargeting, it involves human IK. I guess all the character animation components that were kind of lacking inside of 3ds Max, this is being revisited. Also, from the point of view where a lot of studios work cross-product, right? So some might be working a little bit of Houdini and Maya and Max, and it might always be difficult to interchange models, especially rigs, between these different packages. So we are looking at ways to make your lives a little bit easier right there. And when we talk human IK, of course, there's tons of stuff that is basically happening there, like footstep tracking and basically things that make your lives for game engine workflows as well as for cinematics a whole lot easier. So this is what we've seen. I've quickly talked about modeling, thinking about the Boolean operations at the chamfer, and the environment workflows were about the MCG, the fences, and the shelf filler, that kind of thing. The skinning animation was super brief, but then again, it was kind of powerful to see the heat map and geodesic voxel binding, saves a lot of time right there. And for the rope map, there is stuff in the makes for UV workflows, for automatic retopology, etc. I'll hand it over to Roland. Thank you so much for your patience and time. I hope you have a great evening at Digital Dragons. Thank you. Oh, this is you. Thank you.
I love this transition here. So, okay, thank you very much, Alex. You are almost in time, yeah. So we don't have a lot of time. So I want to actually rush through this presentation. Normally I do live presentations an hour long or so, and now I have to do the whole thing in 20 minutes. So that's definitely too short. So before we actually start to talk about the workflows, I want to highlight one thing that has changed in all our products. So in the past, we did major releases. Once a year you get a new version number with a whole bag of big features. And then every once in a while you get a service pack with some bug fixes, maybe an extension with one or the other new feature and another service pack, and then the next major release. Now this year everybody asks, what's new in Maya 2019? And there's only a few features in there, and people are disappointed. So what we do now is to have a so-called a dot release with a new big number, like 2019, 2020. And then in the next update, you get some more features. So there is not so much in this initial release. In the next update, you get more features, and get more features until the next dot release. So don't be disappointed about Maya 2019. It's a very good release. And, more stuff is coming pretty soon. Did you make that? Oh my God, that's horrible. So in 2019, we have things like, improve the viewport a little bit so that you can see area lights, for example, directly in the viewport, and have a faster and nicer look in the viewport directly. And actually, after that, you will see that even image-based lighting is possible directly in the viewport. And yeah, the Arnold shaders, all the lights look much better and look much nicer directly in the viewport. Also something that most people don't think about because they don't have that problem, selection speed. I have recently some models where really the selection speed played a role. When you click on something and you have to wait for a second until the program figures out what that was that you clicked on. And also, snapping speed is related to that. So the whole algorithm that finds out what's under your mouse pointer is related to that. And then smaller stuff like that motion builder filter that filters keyframes from Mocap data went into Maya. That's very cool because it also works in real time. And then performance, scene loading performance, which doesn't have to do with the amount of geometry, but more with the amount of objects. So when you have thousands and thousands of objects in your scene, it could have been that you wait for 20 minutes to have it loaded. Now you wait only 2 minutes, which is long enough. But that, of course, has become much better. So now let's talk about the workflows. Some of the workflows have been improved dramatically over the time. So when I started with Maya, modeling was still coming from NURBS modeling. And, all of these issues like how do I take a high-resolution model and turn it into a low-resolution model can be, some automatic approaches. But when you want to do it by hand, we have acquired this beautiful modeling toolkit that you see on the right side. So here in this video, you see that we've taken the high resolution, the cinematic model of The Witcher, and started to make it live. You see the resolution is way too high. It's also non-symmetrical. And then we turn it into a live object. So that is my snapping plane. Anything that I have to, anything that I create from then will snap onto that surface. And with my quad draw tool over here, I can start to lay down points directly on the surface. So I can do a world symmetry as far as possible, as far as it is really symmetrical. And here you see on the symmetry plane, it will even snap the points together. So these points that I lay out on the surface, I can then combine by holding the Shift key. Suddenly you see, oh, there's a polygon. You only have to click or hold the mouse and actually draw over the surface to get these polygons done that you can then directly edit. You don't wait for anything or you don't leave the tool. You can just grab everything and move it around, hold the control key to cut things into smaller pieces, and then hold the Tab key, for example, to extend one of these edges. So you can extend a single edge, an edge loop, or the whole border around this object. So you just hold the Tab key and then pull on the border, you pull, extend it on the border, and create geometry like that. So from there, you can keep subdividing, you can smooth things, you can move the polygons around. So it's a very convenient way to start simplifying the geometry. And also the display, everything stays on top of the surface. In the past, it was sinking in and was invisible in parts, which was not very helpful. So that has become beautiful. It's really a fantastic piece of software. And then you can take this even further. So in the next step, what I did here was to load a low-resolution head that I had already and removed all the facial features, the nose and the mouth and so on. I said, okay, while I have this rough skeleton here, I want to snap this to the live head. And so in the past, there was a trick. You select all the points, and then you move them ever so slightly, and then they would snap. So now we have a conform dialog here that gives you the possibility to say, okay, I want to snap it onto the surface or even keep some distance from the surface. And then it does that automatically. And then when you go into the quad draw, you would have this as your beginning of your session. So this geometry is already there. And then you can start to, make it a symmetry model, for example. So now the symmetry depends on this low-resolution model and has nothing to do with the overall shape. It's only the topology. And now you see, I'm just holding the Shift key and creating new polygons, cut them, and everything happens on both sides. You also see it shine through, so it's a little bit transparent, so you get an idea what's happening on the other side, for example, and how the whole thing looks like. You can go directly from there into the multi-cut tool, which gives you, it's a different tool over here, but it has the same visual thing, so you don't have to leave the whole thing and deal with a different look to be able to cut things into a different topology. And finally, so when we go and remove the snapping model, for example, because sometimes it's nice to have the snapping geometry, but at certain points you say, okay, that was it. You know, I've digitized anything I can, so now I want to get rid of it, and now how do you set points into this region here? And that is a fantastic idea from our engineers. You know, when you lay down points, you think like, oh, they are somewhere, but they manage to place the points directly in these holes, and you can digitize the geometry into the air, so to say. So that is a very cool piece. That is the Quadro, or actually the modeling toolkit in Maya 20, when did we come up with it? 17, 16 even. So that was super cool. So there was a leap forward with the whole modeling. And we have a similar, we will talk after this one here, we'll talk about UV modeling or UV creation that is similar. This one here is interesting because normally in the past I thought hair, special effects is not interesting for the gamers. And then I learned, you know, some of the gamers asked us, how can we use, you know, these tools to create realistic hair for cinematics, for example? How can we use that to create hair for our games customers? And here's how it works. So our engineers played around with it to try to figure out how this works. So you have this, you know, nice hair, but it's, of course, in a game engine, it won't work. It's even slow on my laptop with a Quadro card. Now, this was done with the new interactive grooming editor in Maya. So you can really brush the hair, you can manipulate it with that look, so you don't have to do it on any standards. So what I'm doing here is to create a so-called linear wire modifier, which is actually extracting from the existing hair, it extracts the curves. So this yellow stuff here is curves. It's not different from real hair, from the hair that you create, but it extracts hair with an adjustable density so that you can say, okay, I don't want exactly that hair, I just want a thinned down version of this hair with the same, you know, directions of the hair and the same overall shape. You can still grab it with these brushes, you know, the grooming brushes, and modify the whole thing, but it's, you know, it's can be used as for other things. For example, you know, to create geometry out of it. And it works so that we say, okay, we increase the width of these lines, and suddenly these lines become cards, you know, or actually polygon strips that are oriented towards the camera all the time. You can see that when I change the shader here, now you see that it's always, you know, facing the camera. That is cool, but not usable in the game. We don't want the hair to do some weird stuff. So what we do here is to change the orientation. So now the orientation is fixed. We just need to make it properly. So we have a brush that is a twist brush that does the thing here. So it's over here. That twist brush would, you know, twist them around. If you just want to adjust them, you can use that twist brush. But you can also say, hey, I want to align them all to the surface. And I fill that, you know, with the brush, the twist brush can align all of these not yet polygon cards to my camera. And then we have to put this or convert this into polygons. So what I'm doing here is to say, okay, take this hair shape, it is selected here in the grooming editor, and convert it. And you see, that's too high, the resolution is too high. This resolution comes from the hair itself because it's created with a high resolution to be able to, you know, bend it properly and to curl it and to show detail. And then you can rebuild the whole thing with 6 subdivisions along the length of each card, and these are polygons. So I'm changing here just the display to hide the borders, and now you can go in and model it like any other polygon and play around with it. By the way, did you know when you use the move tool, you hold control and middle mouse button and you can move any polygon in and out along the normal instantly. So there's no switching around with the coordinate systems. And all that is left is to create a material for it, and here's your polygon hair, which is really cool. Because, you know, that was a workflow that they played around with as an engineer because it was not laid out, and now it is a tool, you know, the convert to polygon is now a tool. Now, I promised you we're going to talk about this here, the UV texture editor. This UV texture editor is also a fantastic piece that has reworked the whole UV creation, UV modeling workflow. So here I'm taking the body of the Witcher, and you see it just has a planar projection onto it. Because I was cheeky, I said, okay, I have these UVs here, can I do it? Would I be able to lay out the UVs like there? So what you see here is that we have different coloring options. Once was the back and forth side of the polygon, so blue and red. And this one here is showing different shells. So when I cut the thing into pieces, you will see different colors for the different UV shells. So let's start with the belt here, for example. I'm holding the tab key to draw over the thing to select some polygons. I'm selecting some to be able to grow the selection and to get the sides of the belt and, you know, the underneath of this strap here. And then some more leftovers here. As I said, with the tab key, you can simply brush over it and then cut it out. And you see here in the UV toolkit, you have create a UV shell. That's the first way to call that function. So now I've cut it out already. And I would do the same thing with the strap on the side, you know, separate the pieces of it. And once that is done, and of course you can deselect polygons the same way, just hold the tab key. Once that is separated, you go in and cut edges like here. Look here, we have a cut function here. As I said, that's the first way to do it. And cut it again. I don't know if I'm showing the second way already. So the cut function here, but you can also do it in the editor here. So normally in the editor, you wouldn't do anything except selecting things and maybe moving things around. But you can use it as for hotkeys, because here in the UV editor, you have a different set of hotkeys than here. Right? So a Shift X is a different thing here than here. Shift X would be a cut over here, so I can select edges and just move the mouse over and hold Shift X, and suddenly, you know, I get a different result. So here you see the different colors already. I'm moving it away because I can use it for selection later. Now when I select the body and grow the selection, I select this part of the belt already. So part of the belt is selected, and I can use the control selection over here to deselect these faces to then create a UV shell. Or no, I'm going to use my marking menus, because in the UV editor you also have marking menus that are specific to this editor and speed up your workflow. They are, because the whole thing is just about being faster. And then we cut these pieces here, so now we have separate pieces, and I'm using this edge here on the back of the character to cut it. Just Shift X, bing, it's cut, and then these three edges over here, go over, Shift X, bang, it's cut. So you see, you can speed it up. You can use the static button once you are, or as long as you're a beginner, and then after a while you get faster, and you can use the faster methods. Unfold, the same thing. You unfold everything. This one piece here, you have to unfold twice. I don't know why, but at least, you know, in the second time it works fine. And of course, there are functions to straighten things. I'm doing this here manually, straighten things manually. You can sew the pieces together again. That's all no problem. Yeah, I have to jump over to another bookmark over here. There are functions to cut the geometry with a 3D UV cut and sew tool. So you can draw over the geometry and make cuts directly, or double click on tools, on edges, and cut them directly. Hold the tab key and point at something to cut a whole edge loop with a single click. It's really, really user-friendly and very, very fast. So I have to jump a little bit. So I loaded now the part or the layout that I have produced before. So we have some pieces that need fixed here. This one here, for example, that's the body that needs to be cut in pieces. And maybe I can jump over it. You can use a cut brush to just draw over the geometry and cut it into pieces. It's this one here, the cut tool. And of course, you also have a sew tool. You can draw over edges and sew them together. Very, very comfortable. Unfortunately, we don't. Let's have a look at it. It's so nice. Come on. It's a demo where I'm talking. You see me talking, fiddling around with the mouse. So come on, do it. You see? Here again. Bloop. Come on, do it. And then over there, so we do another cut over here. Just draw over it, and it cuts it, and it even separates it a little bit so that you can better see what's happening there. That's the sew brush, so I'm sewing things together. You can, of course, click, select these edges, and sew them together, but that all takes a little bit too long. So I'm jumping over here. So for me as a German, this is not good. A belt has to be straight. And of course, for you, drawing stitches in Photoshop, it also has to be straight. How do we straighten it? I'm selecting edges here, and all of these UVs can be straightened by either the straighten UVs function or by simply scaling them, to a single line. Once I have them in a line, I can freeze them, I can pin them in place. And then when I use the unfold again on this pinned version, then it has to unfold it around my frozen UVs. And then, you guess it, you get the whole thing straight. You can relax it afterwards, but then you have the proper shape. We don't have time to finish this here, but that's, the UV editor and the modeling, these two modeling pieces together are super, super strong. Just go in and look at the pieces that bring you from a beginner clicking buttons, to an advanced person where you hide the complete user interface. You can use the full screen for your viewport and just use hotkeys and marking menus with the right mouse button. Finally, here, human IK character animation. Alex said it already. We have a SWAT character from Payday 2 here that came with a skeleton already. It has the proper naming, so it has a good naming. What I did here was to take this existing skeleton and characterize it. So in Maya characterization means, or in Motion Builder characterization means, we register all the bones by their names, and then we make the skeleton compatible to other characterized skeletons, which means we don't care about the topology. For example, is there a twist bone here, or how many bones do I have in the spine or in the neck? It's all very flexible. You can make skeletons compatible to each other. All we need is a stance pose, and that's what I'm doing here. I'm creating a stance pose for this skeleton, and then lock the whole thing. This lock here means I make it now analyze the rotations of all the bones and make this compatible to another skeleton that is also characterized. And you will see, as soon as that's done, I can apply a full body rig, for example, because it knows all the bones. It knows where the wrist is. And then you can do this to pose your character, to create images, or even to animate. Some companies are using this to animate their characters because it's all fully compatible. And you can use this with our content browser, which is this window here. You can drag and drop character animation. It can be your own library, for example, or predefined stuff, or stuff that you buy. You see, the skeleton is different from the one that we have here, and you can simply pipe the animation of that skeleton into the SWAT character, and then with a blink of the eye, we have the character fully animated. Ta-ta! Is that cool? Come on, that's cool. And that was it already. So I think we don't have time for questions. We will be here. If you have questions, come to us. We'll answer the questions.
Whoa, yeah. Wow. For me, I'm a casual user, but it was amazing. One question, maybe two. Fast like this presentation. But you have to run through the stairs. Oh, come on.
Come here, you get my card, and you can ask questions, anything, almost anything.
Huh. Nothing?
Yeah, everybody's tired, obviously, yeah.
Mind-blowing. Anyway, once again, thank you very much for this presentation.